ahead. Why not let's talk about something that a lot of people oftentimes forget. So hi, introducing myself. I am Gaurav Kushal. Right now a front-end developer at Dynapile. I was the ex-lead of GDG CTIU, an ex-intern at Let's Upgrade. Oftentimes you would find me playing games like Valorant when I'm way too depressed, or other times World and Call of Duty games. So that's about me. Okay. So we are here today at GDG Cloud Kolkata's session, the year-ending meet of celebrating tech. December is the time of holidays, right? We have Thanksgiving, Christmas, a lot of things going around. So happy holidays, everyone. Now, the question is, you guys see a lot of websites, a lot of content all around, right? Let's take an example of an application such as Instagram or Facebook. How is your user experience when you use it? How would you rate it on a scale of 1 to 5? 4.5. Great. 3.2. Okay, great. No worries. Now, on a similar scale, how would you rate your experience on, let's say, a site, a website made by a first year student, if he is not that great in tech?
0.6.
Huh?
0.6.
0. 1 star. 0. Okay. Fine. So, apart from all the functionalities, all the features that they have, what other criteria or factor does it involve in your decision making? Smoothness, right? How fast it is, how robust it is. So that's the question of to optimize or not to optimize. Web performance is some. Oh, by the way, this presentation is completely a Simpsons edition. How many of you are Simpsons fans? You guys will get the references very quickly. Alright. So let's talk about web performance. What is it and why should we even bother about it? As I explained before, web performance is when you're looking at certain websites or web apps. One of the few factors that come into our mind is how fast it loads, how better or how optimized it is to each of our inputs, and how less amount of times does it cause you, does it give you bugs so that you have to reload the site and get it working again. These are some of the criteria that involve inside the big and vague domain called web performance. Why do we need it? Of course not. Talking from a developer experience, if you do not optimize your websites or your applications, you will be called an average mediocre developer. Talking from a business perspective, you will just lose clients. Either way, boss se jhaar milega. So, when we talk about some metrics in anything in our life, when we talk about some metrics or quality of something, we need some tools to measure it, right? Like, we don't have a very great method of finding out how happy we are. I get it, everyone's depressed, everyone's sad. But in order to determine how performant a web is or how optimized it is, we do have some tools that is listed here. We have got page speed insights, Google Chrome UX reports. We have got some Chrome dev tools, search consoles that is also provided by Google. The famous one that most of us use or most of us come across in our early stages of development or career is Lighthouse. Integrated with Chrome, integrated with a lot of different browsers, it gives you good results. Now, fine enough. We know about what to improve. We know about how to look at in order to know the improvements needed. But let's talk about numbers, right? We need some numbers in order to determine that does this particular thing need improvement? Like if you are a grade A student with a 9 GPA, do you think that guy needs improvement? Yes. Yeah, of course he does need improvement in certain areas. But then we also have metrics of CGPAs falling below 8 or falling right between 7 to 8, right? For those, we have got the clear metrics that, yeah, this is the academic score that you need to improve. Similarly, when talking about web performance, we do have some proper metrics. First, the one that is written here is first contentful page. What does that mean? First contentful page, by the way, I'm just going to read it out and then I'm going to explain. Okay? It basically marks the first time when any part of any text or an image of the entire website is painted on the screen. Mind my words, not rendered, not loaded, painted. I'll talk about painting a little bit later. Second is the largest contentful paint. Now, based on the previous description, I think this makes a lot of sense. Like, first contentful paint was the first time it paints. Largest is the maximum amount of time it takes for the largest element to be painted. Total blocking time is what? The entire time duration for which the website will render, perform its layout, and then it will paint, right? Cumulative layout shift. Now, this is a very interesting thing. How many of you here are, preachers or practitioners of piracy? Torrent कौन कौन use करता है? So, in torrent sites or maybe in some illegal sites, you might see, or even some blog sites, for example, you might see that when you first get a page, when you first load a page, and you try to click on an element, the element does not get clicked on, but instead it just shifts below, shifts to the side, wherever, and an ad pops up. Right? Yes. So this shift in the layout from what we are shown initially to the entire process when the render is complete. If there is a shift in the position of the element, these things affect the cumulative layout shift. So the metrics will be 0. If there is a difference, it will be shown accordingly. And finally, speed index. I think it is very self-explanatory. What is the speed and all that? I won't be going too much in depth about all of these topics because these actually were covered in GDG Cloud Kolkata's IO Extended by Somadip Choudhury. In the speaker notes, you might find his slides attached, or even in GDG Cloud's Twitter handle and LinkedIn handle. You can find that slide. So, good luck exploring. Now, these are some of the differences that you can understand and see. What makes a website slow, or what metrics make a website tell us that a website is fast. On the left, we do have a performance score of 38. I'm not going to explain how all of that scoring is done. But then again, and on the right side, we have got a performance of 97, accessibility 85, 73 best practices, 91 of SEO. Finally, we have something called a PWA, which we will be covering in the next half of the talk. Now, obviously, I don't think I need to explain much of this. Even if the metrics don't explain much, I hope the illustrations will. Right. Now, we talked about metrics. We talked about what needs to be improved. We talked about how to know what to improve. Now, let's talk about actually how to improve. This topic written right here, critical rendering path, is the first topic that I believe every web developer in their life should learn. I have received a lot of guidance in my college. I have seen people give guidances to other people. Most of them are in college. So I'm not talking about the professional life, most of them are in colleges. That whenever someone asks for a roadmap of how to learn web development, HTML, सीख लो, CSS, JavaScript थोड़ा time लगेगा, then pick a framework and move on. This is the typical roadmap that people are given, and this is the typical roadmap that most of the times that you do find on the internet as well. But before learning about languages, we need to understand some of the definitions, some basic theories that affect. How many of you here are, I wouldn't say proficient, at least on an intermediate level of web development? How many of you are? Okay, what else? Who else? Okay, sorry. How many of you have started learning web development? And how many of you are experts in it? Okay. Can you tell me, does anyone here know about this term called critical render path? Anyone? I don't have a problem if you are wrong. I don't have a problem if you do not. Because, let's be honest, 8 months ago, even I did not. So it's fine. We talk about writing a website in HTML. We talk about various big topics like WebAssembly, in which we use other languages, other tools in order to create stuff for the web. We talk about cross-platform applications like Flutter, for which we have Flutter, right? But in the end, everything comes down to what? Browsers, because that is where you are going to see your content, right? We need to understand how a browser loads the website, how a browser can parse the entire thing, make sense out of the HTML you have written, and create it into a proper website. Once again, I have added some detailed topics or a list of steps that the browser follows in order to render an entire website. You can find them when you get the presentations. And let's talk about it a little bit. What is the first thing that happens when you load a website? Let's see. Yeah. Anyone?
The basic layout first loads.
Basic layout first loads. Anyone else?
Then the design.
Yeah. What is the first thing? I want to know about the first thing that happens.
It sends a request to the server.
Correct. It sends a request to the source from where we can get the files over a network. Right? So that is the first thing that happens. The second thing what happens? We have got our files. Now we know what to look out for. What we will look out for in the first place? The HTML file. Right? So once the HTML5 file is received by the browser, it parses it. It may or may not encounter, depending upon the type of website, a JavaScript script, right? What happens? Browser then proceeds to parse the script, compile the script, parse the script, whatever you wish to call it. Based on the script, the entire HTML DOM is created. You guys know about the DOM, right? Document Object Model. So, parsing HTML is a render blocking time. That means what? Whenever we are parsing the HTML, the browser allocates all of its resources to that, and only after it has been parsed will it move on to the next. Then it does what? It proceeds with the JavaScript. It will parse all your JavaScript, look for errors in the code. If there is an error, it will give you reports and all that. Fine enough. While parsing JavaScript, while creating the DOM, we encounter what? CSS files. We encounter styles. CSS, remember this, is also a render blocking process. That means what? When the browser sees some CSS is present, we need to parse it. Then it will go ahead with its usual parse. It will create something called the CSS object model or the CSS program. Once all these three things are done, the document object and the CSS object model will proceed to okay. These two proceed to create the what we call a rendered tree. Right? Rendered tree is created. Then we need to, the browser then does what? It does a geometrical positioning of all the elements depending upon where they are present, what is the margin, what is the height, width, etc. Finally, we did talk about painting in the last slide. Finally, we paint. Any idea what this paint process will do? It's a very common answer, or very you can use your common sense to come up with this.
Load the website. Load the website.
No, it's a very vague term. Load the website. I want to know something very specific. What does the paint do? Anyone? Batao.
Show the basic skeleton of the website.
That is in the layout process.
Paint the graphics on the plan.
Not on the plan. It basically just colors all your elements of the scene. First. Pati wrong in this. Okay. We talked about sorry, we did not talk about optimizing the critical data. We talked about the critical data. Right? Now, how can we optimize it? Since it is evidently clear to us that parsing HTML, parsing CSS, and even parsing JavaScript is these three things are render blocking. That means the longer time it takes for one of them to be rendered or one of them to be parsed, not rendered, parsed, the longer will the entire duration of the wait will be. So, if you have got a JavaScript, if you have, let's say, an unattended infinite while loop, do you think the other processes will work?
No.
Of course not. So that is the problem with these. Similarly, if you have got a very big piece of code that requires a lot of memory, that requires lots of computation, do you think that the website will be fast enough to do that entire process? Of course not. So how can we improve on this? Firstly, we do have the as developers, we do have the power to prioritize things on what needs to be loaded. For example, let's say you just click a new tab in Google. You get the initial UI where you have the Google's homepage, you have got the search bar. Now we may not know what different computations go behind it. Well, let's say adding some what do you call it? Insights function, or if it wants to load some ads, whatever. We don't care. Now, we do not need those big chunks of JavaScript, or we do not need those big chunks of script in the first phase. Does it make sense for us to load all that? It does not, right? So, we have got something called lazy loading, so that we can prioritize the things that we need to load first, and then it's the entire DOM, it paints the entire thing. Once everything is done, after that, as required, then only we will proceed with those resources. Another example can be, let's say you open a website which has got a proper landing page with a video, an audio, and texts. The first thing that you see on the website. Down below, way towards the bottom, you have a testimonial slides, या फिर a team slides which uses something called a carousel. Now we all know we use some packages. A carousel package is a very big thing. It takes a lot of time to process, a lot of time to parse. Does it make sense for you to load that in the first phase? Wait for the entire thing to load here so that I can view something that is up here? It does not. If you're having difficulty understanding this concept, imagine you want to watch a particular part of a movie. Now, instead of streaming that particular part of a movie on Netflix, Amazon, whatever, you proceed to download the entire thing and then watch it. Is this example better? I know energy down. Yes or no?
Yes.
Great. These are some of the ways that you can use to optimize the critical render environment. Second is CSS. Now let me clarify this part. Optimizing CSS does not necessarily mean that your website will, if your website takes, let's say, 12 seconds to load, I will not guarantee that optimizing your CSS will bring it down to 1 second or 2 seconds. Because most of the optimizations that you can affect your speed by maybe microsecond or worst case a second. This is the type of optimizations that can be done. Now, what are they? Let me tell you guys one thing. Let me give you guys some context. This is such a topic that can be explored by a developer at any point of their life. At any point of their career. They can start learning it at the beginning also. So if you guys are new to web development, this is one thing that you can always look out for, and no need to wait till you become a proficient web developer to do it. And also if you're a proficient web developer unaware of these concepts, then you can also learn this and improve your sites better. So in CSS, when the CSS parses, we have got something called a specificity calculator. That means what? How specific do you want the style to be, or how specific do you want a selector to be? For example, let's consider out of the boxes. You are outside returning from college or from your work, and your mom calls you, "Asar সময় একটা বিস্কুটের প্যাকেট নিয়ে আসো." Makes sense. Happens to a lot of us. Will happen to me today. Fine enough. I was just told a packet of a biscuit. Fine. It's very vague, right? I don't know what type of biscuit. Toast biscuit, normal biscuit, Britannia biscuit. I don't know, or even Parle-G. I don't know. But if my mom specifies that sun-feasted dark fantasy dosta car packet, it becomes very specific, right? Now for CSS also, this same concept applies. The more specific you target an element, the more time will the browser take to understand it and parse it. Keep this in mind. The more specific you get, as a developer experience, it might be really great. But when the browser parses it, it will take more time. It will cost you more. So the key here is to understand or come to a balanced point where you can have this selector as much vague as needed, but yet as much specific as it needs to. Second is break down the CSS into separate modules. Instead of having all your styles in one folder or one file, break it down. Break it down as it is required. Third point is I would request you guys to check out what CSS sprites are. Okay? I will not be covering this because this is a very interesting topic that you can search. Okay. Finally, we all know that we can animate elements, right? We can animate elements in the web. We just go from, sometimes if you want to create a blink emotion, blink animation, we do one, opacity 0 to 1, something like this. We can animate other properties as well, like margin, padding, etc. But remember, these things now affect the layout and thereby affecting the browser renderings. Okay? So these are very expensive properties. Do not animate them until and unless it is really required. An import statement, sometimes when we get fonts maybe from Google Fonts, we all often try to use the import statement, right? But understand this concept very clearly. I said CSS is rendered or CSS is parsed, not rendered. CSS is parsed once the browser can detect it. So if you have got a font that you are loading via CSS, it will wait till the CSS file is fetched, only then can it fetch the font. So initially you might be seeing a different font, and at the end you might be seeing a very different font. So to avoid this, use the very great element or very great element that HTML has provided us, the link. Okay. Lots of other ways to optimize CSS. I forgot to add one more point. Please try to minify your CSS files. By that I mean remove unnecessary blank spaces, unnecessary extra lines, empty lines and all that.
I have a question.
Yes.
Can we customize a render tree, or it is customized as per the code is set?
As per the code is set. You can maybe prioritize something first, or you can maybe offload it for something later. For example, when we are working with JavaScript, you can see in the third point that we have written something called a link rel preload, right? What does that mean? Your browser will make it a priority to load this particular script or this particular module. Once again, if you want to offload or if you want the JavaScript parsing to go in a parallel process, not inside the singular serial thread, but in a parallel process. What you can do is use something of a keyword called either defer or async. Once again, okay. So now remember this: JavaScript constitutes your entire script, right? If you import packages for a very menial task, for let's say if you want to just perform an addition, are you sure that you need an entire package for that? You can just write it. So keep in mind, you don't always need a frame. If your particular logic can perform a certain function with ease and you do not need a package for it, please don't. Enough other ways, go through it. I know you guys are hungry. All that. But yeah. Lazy loading, once again, I have already mentioned it, the usage of keywords like defer and async. Okay. There is a very good blog on Blog Rocket that you guys can search for lazy loading images. Images are the one of the most heavy resources that constitutes a website. Some images can be of 100 KB, 2 KBs, and some even go beyond 1 MB. So, in order to uh, you know give the customers or give the users a better experience, try lazy loading those images. What do I mean by that? If the image right now is not visible in your screen, you do not need to load it. Once the element of the image comes into view or is in the close vicinity of it, then only load the image so that your performance gets better. These are some of the other things that you can actually look out. Right? You created your entire website. You optimized it. You think what? A website is done. Website is never. We are going to talk about this not PWAs. When we were looking at the image in the lighthouse, we saw there's something called a PWA associated with it. So what is a PWA? So live stream, I cannot say a few words, but okay. Basically, PWAs offer you one alternative to native applications. That means what? You have got, let's say, Pinterest app on your phone, right? A lot of people have that. We also know that Pinterest is available on the browser. Pinterest, in fact, is also available as a web app, a progressive web app. What does that mean? It will run on the browser, but it will act like a natively installed application. Okay? And the best part is, while the Pinterest application might take around 16 to 20 MBs of disk space, the PWA version will not be, not guaranteed, but it will be very minimal, maybe 1 MB or 2 MB max. That is the beauty of what PWAs are. Does everyone here have a proper net connection right now? Or most of the people who do, try this out. This is a small application or a PWA that I actually made for this particular session. So it goes something like this. Take this .netlify.app. Let me just open this up. Basically nothing. It is just a normal note-taking app that works on local storage. So you don't need to worry about signing in, giving your details or any of that stuff. And no, I cannot read whatever you write. So yeah, something about text. If I do that, fine enough, I send it, gives you a confetti saying that yeah, you have done something great, and then this happens. So I also do in fact have a PWA version of this. It is installed on my system like a native application. It acts like a native application. Now, because it is connected to the streaming, I cannot turn off the internet right now. But here is what you guys can. Once you go to this, particular website, find a pop-up coming up, maybe after 1 or 2 seconds. That add thing to think about this to your home screen. You will see it installing as a native application. And the best part of it is what? When we do not have an internet, what do most websites do? Bye-bye. They just go bye-bye. No internet connection, you see the fancy dinosaur game pop up. But the best part about this PWA is, even if you do not have an internet connection or an active internet connection, this will still work. This will still work. If you guys have installed it, write something, let it cache, and then you guys can see that it also works off it. Right. Now this is just the bare bones. I'll be talking about the bare bones of the PW. First is how to get started. What do you need? Firstly, you need a website because otherwise, what you're gonna make an app on? Secondly, is something called a manifest.json file, and the third is something called service workers. Lastly, setting up a PWA takes a bit of time, so have some snacks and enjoy. I'll rush through this part a bit because this requires you guys to study it, and no matter how much I explain it, it won't matter that much. What does a manifest.json file do? It just gives you some specifications for what your app is, some metadata, if you might say. For example, the logos that you see about the app, and when you open it, a splash screen, these details can be configured using this. It looks something like this. It's a JSON structure with some of the fields for name, short name. Start URL is basically where you want your app to start. Does it start in a default login page or on a for an e-commerce, let's say on the products, something like that. Icons are the ones, I guess it's self-explanatory, that you guys can, just create your icon, store it, and it gives you each icon file size, etc. Service workers are the best part that make a PWA possible. What do these do? Service workers run outside the window object of a JavaScript. They run independently. They will install on your system. They will activate. And the best part is, even if you do not have an internet connection, these will still work. But remember this. This is not something out of the box. This is still a JavaScript file. Okay, it's just still a script that runs even when you are not connected to the internet. If you move ahead to the presentation, you guys can find pieces of codes that define you how to write service workers and what are the functions that you need to create a PWA. The first step is you need to register the service worker, not going through the code, because I know you guys won't understand it. It will be a complete waste of time. I know. So yeah, please study on your own. If doubts, reach out. Then you set up some because cache files are the ones that will give you the data you need for offline connectivity. Then you need to install it. Because of course, if you do not install a service worker, how the hell it is going to know that yeah, I need this particular thing. Finally, activate it. Because we have got our key, we have got our car, we have put the key in the ignition, we need to start it. That's activating. Finally, these are the three life cycles. Service worker will install, it will wait for everything to set up cache, whatever, and then it will activate. And this particular piece of code, I guess, 1, 2, 3, 4, 5, 6 to 7 lines of code is what you majorly need for setting up offline support. Now, remember, this is just for the bare bones. If you have got complex structures, this thing will not work. This thing will work only up to a limited scale when it is in like the app that I provided. Now, how do we go into the advanced steps? Like I said, don't always try to reinvent the wheel. Google has provided you with a wonderful package called Workbox that just makes your life entirely easier how in order to set up a PWA. With packages like with frameworks like Angular, Next.js, etc., they give you native support on their CLIs for PWAs. And if you want to ask about other stuff, other languages or other frameworks, go to this Hacker News PWA. This website will give you a detailed blogs about how to integrate PWAs with different kinds of frameworks. That's about it. So feel free to get in touch. Okay. If you guys have any questions, feel free to reach out. And please don't ask for a WhatsApp. A lot of people do that. Thank you. I give the stage over to back to Stan.
Okay, thank you, Gaurav, for